Hi everyone. This presentation is a follow-up to one I made a few months ago, so that is relevant context to what I'm going to be talking about today. I've implemented some changes to my fitness data-driven agent. The main changes have been migration to a lakehouse architecture and implementing a semantic layer. The timeliness of this video relates to the Apple WWDC conference for 2026. I have reason to believe that they will introduce some AI-related features, so it's timely for me to get this out before that happens. While the first video that I made, the inspiration was Wildruff's ChatGPT fitness coach, this presentation is more inspired by the work of Andrey Karpathy. He went viral early last year, by introducing the world to the term vibe coding, where instead of copy pasting from the browser to your editor, you give into the vibes because you trust the agent, because you trust the large language model, because it has just gotten so much better. And it dawned on me, a similar thing happened while I was testing and working on this fitness agent. Initially, you don't really trust the large language model because, especially when it comes to coding, you don't know what it is, but it turns out to be useful. Then you find out what it is, like a token, next token. It fills in the next token. Whatever the architecture of a large language model is, it doesn't sound very convincing. But you go from distrusting it to using it more, then it gains your trust, and then it becomes indispensable and something that you rely on. So that happened to me, and I realized that I'd rather just give into the decision-making process of the large language model. But if I'm to do such a thing, then the data itself becomes quite relevant, because you can't have stale data. The agents by default are quite dumb compared to large language models, which are quite resourceful. And the reason why agents by default is quite dumb is because they do what you have scoped their context to be. And if you don't intelligently design what they can decide on, they can be quite dumb. So it might tell you to do a hard training block after you've had 0 hours of sleep, for example. So the data becomes a challenge. I have an analytical background rather than a software background, so I'm more likely to think in terms of OLAP databases than OLTP databases. So OLAP being things like DuckDB and Athena, when OLTP being SQLite. But that background led me astray, because the way to properly engineer something like this would be to use an OLTP database, transactional upsert. Another thing to keep in mind, just as a foreground of what I'm about to talk about, is the automation, or the app can be quite brittle. It relies on two things happening consecutively, triggering one after the other. The first thing is, nothing happens if you do not touch your phone. If you don't wiggle it around, you don't unlock it, you don't open an app, no data can be sent. The second thing consecutive to that is, you need an internet connection to send a payload of whatever the megabyte payload is, maybe 5 to 6 megabytes. And if you run out of cellular data, perhaps you're outside, no automation can be triggered. So that means that data deduplication should be part of the pipeline. In my earlier architecture, if you look at the diagrams, only export 3 was sent. So there was no timely data throughout the day, which means if you were going to ask an agent something, it's always going on stale data. However, that's just the design of OLAP databases, which are append only usually, and the overnight scheduled append only file dumps. If you're going to do transactional upserts, which is what I've migrated to, you need to have a data deduplication process built in, and for that I'm using the Duck Lake OLTP upserts. Another thing to mention is that my workouts pipeline was exactly the same as my health metrics pipeline. But the problem with that is I was forced to do that because I was encountering the problem of the post request data being too large of a file. So they can be quite large because it's by the second. So the way I worked around it in the previous demonstration is I just made it by the minute, which makes it easier, but it reduces the complexity of the data. It loses the fidelity. So what I've done now is a form of data chunking, so type 1, slowly changing dimension. So it doesn't matter that the data is timely, I just need data fidelity. So over 2 payloads, one is root data by the second, the other is health, like heart rate recordings by the second. With Duck Lake, I should emphasize that it's possible to also have an append-only pipeline. There's some documentation around how you can do that, but the way I want to move away from that, which is what I've done. And an excuse to use a data lakehouse is an excuse to use Duck Lake, which is the newest table format. You can use other table formats. I was drawn to Duck Lake, Duck Lake because I found it easy to get my head around, and I had such a good experience with DuckDB, and it was easy to get my head around the simplicity of Duck Lake compared to other table formats. I like the lack of file generation just from table inserts. The documentation was well explained, so that's what I've chosen. You could probably choose other table formats. I do not see many people talking about this flavor of stack, this flavor of Duck Lake. It's called a BYOB Duck Lake, and BYOB stands for Bring Your Own Bucket. So I've circled in red what my specific implementation of this pipeline is. It's entirely cloud-based. I'm using Amazon S3, which is what I was using previously for storage. And the good thing with S3 is the 9 nines of reliability. There's very little outages, so I trust in the infrastructure. For metadata, I found the cheapest for me is to use a duckling from Mother Duck as my metadata storage. And in terms of compute, I'm using a Lambda serverless function on AWS that'll be processing my upserts. And the other thing is I'll probably using a cloud server if I go on to deploy this fitness agent in Vercel, say. But as a prototype, I'm just testing it locally on my laptop. But like in terms of deployment ready agents, it might be entirely cloud-based. The good thing about Duck Lake as an infrastructure is that it's quite interoperable. You can shift things around, going from local to cloud. And the reason why you might want to do that is because with health data, confidentiality is quite important. So you might want to go for an entirely local stack if you're worried about data leakage of confidential, intimate data about yourself. I did not talk about my cloud diagram last time. I didn't dwell on it, but it is quite important for this presentation because I've come to the realization that what I'm talking about is not that original. It's not that innovative. Wildruffer and like other YouTubers have been talking about ChatGPT fitness agents for months or years. So the architecture or the execution is the product. Something that came up only during testing is that Garmin Connect workouts are quite heavy in terms of data. So most workouts are recorded by the second, and Garmin records quite a lot of data per second of workout, and that can clog up the post requests by Apple HealthKit. So I've decided to disconnect Garmin Connect from data being pushed to my servers. Another problem I have encountered during testing is something called the lambda asynchronous limit. So it can be intuitive to think that, oh, you send the data to an API gateway, then that data can be directly upserted through a lambda function into the mother duck metadata store. However, it's an annoying bug which limits the data upload capacity to 6 megabytes. So what I've instead done is an event-driven pipeline where the API request first gets pushed to S3 object storage, and that gets processed by a lambda function, which sends it to mother duck. Another thing worth mentioning is that compared to my earlier data lake infrastructure, the lambda function itself can be quite expensive, not in terms of costs, but in terms of compute, because what you're doing is quite complicated. So we're dealing with a lake house with about 11 million or so rows, quite a lot of data, and filtering that data by the time period of the upsert data period consists of doing a filter, then doing a comparison, and then doing an upsert, which requires more compute than, say, 256 megabytes of RAM. Importing DuckDB into the Lambda function can increase the cold start as well, so maybe a minute or so of processing time rather than 30 seconds. But I believe it's worth it to be entirely serverless, which is what I've implemented. Something that I alluded to in the first demonstration, or the first presentation, was this idea that Apple has all of your data, and that informs my choice of hardware for this general idea of project. So you can do something similar with a competing array of fitness devices. I do not think you'll get the same kind of experience as what you'll get as compared to what I've implemented, and I'll talk over that, mentioning the figure in the slide. So first thing to mention is that if you imagine in your head what like a data enthusiast looks like, you'd probably think of a cyclist who has like all sorts of sensors on a bicycle capturing things like cadence, torque, power, that kind of thing. Cyclists are the original data geeks or data enthusiasts. My issue with that is they don't collect passive data, and passive data is quite voluminous, or like it's quite extensive, and it can be, in my opinion, quite informative. And you'll never have that sophisticated of a fitness agent without your lifestyle data. And this is just hot off the presses. Stride has implemented something similar to what I'm talking about, sort of a fitness agent conversational interface. However, they don't have your passive data. They only record your workout data. So it will never be as good, despite being quite polished, I'm sure, and quite professional. I'll talk over some of the other parts of the slide. Oura Ring. So this type of hardware does not have, it's just a ring. It's not a watch. With my Apple Watch, if I'm walking, or if I'm doing anything, it'll say, hey, you're doing something, and then I'll press, okay, I'm doing a workout, and I'll press the exact workout I'm doing. And that's quite relevant data. So my heart rate might increase from resting to 90 by doing either like a core workout, just doing sit-ups, or just going for a brisk walk. And I can tell you, having done both, that a brisk walk is much less taxing than getting your heart rate up from doing sit-ups. So I just don't think that the passive data from Oura is as informative as it could be. The last thing to talk about is, on this slide, is that Google does a similar thing. They basically cloned what Apple have done, and they're quite polished. My issue is that I don't trust Google the way I trust Apple with my personal health data. So I'll never implement something like this with Google, because I'll never give all of my fitness or health related data to Google in the first place. I'll never let them record my life and have it go to their servers. But I trust Apple, so I've implemented this with Apple. And implemented this with Apple as a backend so that Garmin can handle my workout insertion. What is not mentioned in this slide is Whoop. similar to the Aura Ring, the reason why I don't even consider it's a non-starter for me, because they have a subscription revenue model, so you don't really own your device and you don't really own your data, and I consider that anti-consumer, and I would never willingly use a product like that. So I've talked about the lakehouse architecture. Another thing that's quite straightforward to mention, but it requires you to elevate yourself in terms of your knowledge, is this idea of having a semantic layer in the data. In the demonstration I had last time, I had a bug just because I engineered something wrong. But there was a deeper problem, which is that I did not implement a semantic layer. And the data agent doesn't have the same... So it's always fresh. It doesn't have the experience that you do, like just playing around, exploring the structure and so on. And it can be easy with a personal project to forget about how you personally know what the data is like. So if you're thinking about like health data, you might think, oh, to get my heart rate, I'll just say select heart rate for the relevant period that I'm interested in. But with this IoT snapshot, it's you need to they're independent snapshots, one after the other, that go into the table, and you need to filter to get the type of metric that you want first. And it can be easy to forget that you need to do that filter first, and the agent can trip up there. So you need to implement a semantic layer so that the agent doesn't get stuck. That's something that I forgot to do last time, or I wasn't even really aware of for a personal project. It doesn't it's not front of mind like it would be in a commercial context. But I've implemented it here. It's just a collection of SQL views, perhaps a few dozen or so, because there are so many different health metrics. And what became of the TRIMP algorithm? So all I've done is I've iterated and tested and seen what works for me. So like I can easily tell the agent, look, I don't like it when you make it all easy. I don't like it when you make it all hard. I don't like it when you make it all boring. And I've implemented a bunch of constraints, as well as what are the opposite of constraints, like giving leverage or giving leniency to the model. So the agent needs to have both in order for the workouts to be tailored to what you're looking for. Okay, thank you. On to the demonstration. Okay, hello everyone. The first thing I want to do as part of the demonstration is to demonstrate how this is close to real-time data. So what I'm going to do now is query the Duck Lake from the command line, and you'll see a date time of the latest data in the Duck Lake. For reference, it's about 2 p.m. Currently on the 3rd of June, and we're getting the most recent data is basal energy burned around midday. So now I'm going to send what the latest data snapshot for today would be from the app. Okay, we'll try now. So this date, it's closer to the actual real date time, and it doesn't matter what metric is shown. It's a different metric, and it's quite close to the time that I'm actually speaking right now. The next, what I will do is I'll ask for a workout for today. I'll send the manual. The workout automation should come today at any day, but it's only midday now, so maybe it'll come later in the day. That just shows how unreliable the automation is, but I can manually send it. It'll be 2 chunks. We can quickly look at from the command line if it's the latest data. It's 2 days old. That's more recent. So the agent should allow me to ask for a workout today. Before accepting the workout, this is what the training calendar looks like currently. I'll accept the workout. Now, the workout should be in the training calendar. It's loaded automatically. I don't need to refresh the page. What I'm going to do now is inject a synthetic workout to the duck lake, because I can't go into the future to demonstrate this. What I'm going to do is I'm going to undershot what these workout structured bands are, so hopefully I'll get feedback that my efforts aren't matching the prescribed blocks. The effort is too low. Now we'll just pretend that I've done the workout, because the synthetic workout is in the duck lake, and I can ask for feedback now on how the workout went. It's saying I didn't match the effort of the workout, which is intentional. So now what I will do is I'm going to move the calendar a new day by injecting fake daily metrics. Okay. On Thursdays, contrast to Monday, Wednesday, Friday, I typically don't go for runs because I find running every day a little bit tedious and boring. So instead, I'm going to say that I do Pilates and yoga. I also need to inject in order for me to ask for a workout on Friday, I'll inject some readiness metrics as well. So the agent now thinks that it is Friday, so I'm going to ask for a workout that will be pushed to my Friday training calendar. So I will accept this, and it should go to my training calendar. If I the training calendar, there's now a workout, and just like before, I'm going to upload a synthetic completion of this workout, but unlike on Wednesday, for Friday, I'm going to overshoot it. Like, I'm going to give too much effort, and hopefully the agent will give me feedback that my efforts aren't matching the workout. It's too much. Now I'm going to ask the agent for feedback. The effort is probably too much. It says broadly that I went too hard, and that was not what was prescribed. So now the calendar is at Friday. Typically, I don't do structured training in the weekend. I explained that in the previous presentation. So for the weekend days, I'm just going to have synthetic long walks, and that will progress the calendar 2 more days until the next day we'll get to Monday. It'll be a week's worth of training. Now the weekend is past, I'll just inject some readiness metrics for Monday before I ask for another workout for Monday. So it's Monday and I will ask for a workout. I think I was supposed to put it in quotation marks. It's supposed to be in quotation marks, I believe. Okay. On my training intervals.icu, it should be there. Okay. I will inject the synthetic workout execution, but in this case I'll do it perfectly, just to get good feedback. So this workout was perfectly executed because it was fake, and hopefully the agent will give feedback that I executed the workout properly. Okay. Okay, it seems to broadly say that the workout has been done at the right intensity level. So this is more or less a week's worth of training. So it's at the stage where you can start asking for long-term progress. So I will do that. So it's giving a rosy picture. Should be giving a rosy picture because I've injected some fake data to show that I've made progress. Okay. So that was something correction of an error from the previous demonstration. Now I can ask it sort of a curveball question to test the text-to-SQL functionality. Okay, so this corrects another error that was in the previous demonstration. It's giving an answer, it's data-driven, it's not like, it hasn't been primed to answer this question, it's using genuine intelligence, I would suppose. Okay. Also the SQL node, before it was just like a single node, but there's quite a lot to it, and I didn't implement this correctly in the previous demonstration.